Hello and welcome. In this video I will walk you through how to prepare a Taycan high voltage battery pack for an energy storage system using LinkBMS. Disclaimer: hazard of high voltage, specialized training required, strict safety procedures are necessary to build such system. Never do it on your own, always take second person as a company and prepare everything to make it as safe as possible. What you can currently see on the screen is Taycan battery pack 85.6 kWh setup inside a rack cabinet, complete with our in-house battery switch, link master, LinkBMS.eu and other essential components. Okay, so the first step that you want to make in order to build that kind of pack is, of course, make a voltage measurement. In order to do that, prepare yourself a setup consisting of 5-volt 2-amp battery source. In this case is an ordinary power bank connected to LinkMaster, and an Android or iOS device that will be connected to the same Wi-Fi network as LinkMaster. Okay, so you may ask, why are we measuring every cell in every module? What do we need it for? Porsche Taycan developed a problem inside their battery modules, which is self-discharge. We are looking for bad cells that are inside every module, can be in every battery pack, because the main reason why this end up in landfill is because they are rejecting it from using it in the car. So we are looking for 1, maybe 2, sometimes 3 modules that have one faulty cell inside, and of course it will be shown in the spreadsheet with data analysis that we will do later. Okay, but first we need a plug that we can put directly into the Taycan module, and of course to LinkMaster in order to get that results, which is 4-pin TE connectivity wire that has latching mechanism that we would like to remove in order to make the process simpler and quicker. So I will show you how to remove this latching pin the easiest way and make the measurement very easy and quick. In order to do that, prepare yourself a sharp knife, take your plug, put the knife directly onto the latching pin and just cut it out. Using a little force, it will just pop right off. Prepare yourself a setup that is shown here on the video, so the power bank, LinkMaster and some kind of Android or iOS device. Make measurement of each pack, put it directly into a spreadsheet and look for any deviations of voltage inside the packs. To be sure about the voltage measurement, make it twice, just after the purchase and try to make it just before an assembly. We here in our company are trying to make this kind of measurements that is separated from each other within 3 months. So first measurement in June, next measurements 3 months after. And this makes us 100% sure that we don't skip any of self-discharge problem within battery pack, and it proves that this will make a long-lasting battery pack for energy storage solution, because we don't have faulty cells inside at the beginning. Okay, so in order to make a first measurement, you need to prepare yourself a LinkMaster device configured by 1 unit, 1 string, 1 slave, 6 cells on 6S slave module. And after that, connect directly to, by default, bms.local, and you will have 6 measurements of 6 cells and 6 voltages that you are interested in. You put it directly into the spreadsheet and then compare your results within next cells and make 2 measurements, as I was talking previously, in order to be sure you don't have any faulty cell inside your battery pack. The next thing that you want to do is make it as safe as possible. So we are splitting whole 660 volt battery pack into layers that consist of 3 22.2 volt battery pack that sums up to 66.6 volts nominal DC. This is considered safe, and we are then connecting it using high voltage DC connectors and close everything up with a key. All this is then connected to a battery switch. This is 1200 volt DC battery switch, which we connect in parallel in order to acquire 64 amps of continuous discharge on this switch. And after that we connect it directly to power delivery unit, which is 50 amps, so we have plenty of space in that kind of current consumption. And then the PDU is connected directly into Staubli Evo 2 connectors, which also are specified for 70 amps of continuous discharge and 1500 volt DC voltage. We put CAN and Ethernet connectors on the enclosure in order to make the connection to LinkMaster as quick as possible. And after that we are connecting it directly to Taycan battery modules, 15 battery modules per string using TPL1 communication protocol, and the wire that I was showing you previously. This is the wire, and the very important part about this wire is that it has to be correct length, correct resistance, correct inductance. This is specified in TPL1 protocol datasheet that is provided by chip manufacturer that we use, and we follow the instructions in this datasheet in order to make that kind of wire loom. It cannot exceed certain length, so we are preparing it within the specification. Of course, each part that was shown in this video can be purchased directly from us, so feel free to contact us through email. The email is in the description of the video below. If you have any questions regarding the build or any questions about the LinkBMS system, just leave a comment. I will try to answer them all. Thank you again for your attention. See you in the next videos. Bye.